Okay, so now we're actually going to start this for the real deal. So I'm going to wave my hand, and I'll remind you we'll have time for asking questions at the end, to use the microphone here at the desk. And if yours doesn't work, I'll come around with the handheld mic. So we're pleased to have Dr. Jean Wolfe with us today. Dr. Wolfe is the founder of GeoStats. She has a PhD from Georgia Tech, and she's going to discuss measuring travel and physical activity using GPS and accelerometry for transportation and health applications. And I'll let her take it away, and she can tell you a little bit more about herself as well. Thank you.
I want to thank you for having me here to do this presentation today. GeoStats is a company that's been around since the summer of 2000. I started it after I finished my PhD in civil engineering at Georgia Tech. The company is focused on applying new technologies like GPS and GIS to collect and process data centered around transportation studies. And the physical activity became a natural extension to our studies right from the very beginning. And so that's what this presentation is about. So I'm going to start off by giving you some information about GPS applications and household travel surveys. And then I'll move on to how accelerometers are being used in physical activity studies, and then how we can bring these two technologies together and actually answer questions about travel and physical activity in the same study framework. So household travel surveys, if you know anything about them, these are surveys that are done at regional, statewide, and national levels to collect information about populations' daily travel patterns. And people, representative households, report the trips that they make in a given day and the origins and destinations and the characteristics of all trips made by all members of a household. And that data is then aggregated and used by transportation planners for their travel demand models as input into how the current network is used. And then they can do scenarios in the future about what would happen if a road was widened here or a new bus service was added there. In the U.S., the primary method for conducting these travel surveys has been the use of travel diaries that are distributed to participating households. And these households are typically recruited by phone. Diaries are mailed to them. Then the telephone interview is conducted to retrieve the travel information over the phone, with the people reporting what they've recorded on their travel logs, if they actually recorded on their travel logs. And it's pretty well known that self-report methods for reporting travel are not always accurate, because some people will misreport trips or trip details for a variety of reasons. They may intentionally do it, or they may just forget, or they may do their own screening of, well, that's not really a trip, so I'm not going to tell you about that one. Sometimes when the interviewer calls the household, not all members are available to actually report their information. So sometimes it's the wife reporting for the husband. She may or may not have his diary available. And so this method is used because it's an efficient method to get very large population samples conducted. But with the advent of global positioning system, I think everybody here probably knows what GPS is by now. In 1996, Federal Highway Administration sponsored a pilot to look at, well, can we use this technology to help us collect detailed trip information and possibly use it to either supplement or replace the way that we do things. And so it has been around for the last decade. And the devices that have been available, and these aren't just GPS navigation devices, but these are GPS data loggers, so that they have the ability to receive the GPS signals from the satellites and then calculate a position and then store the position on the device itself. In the late 1990s, early 2000, there really weren't a whole lot of devices available that were small and lightweight and easy to wear that also could log data points. And so the very first studies that came out the gate were really vehicle-based studies where GPS equipment was deployed for installation in household vehicles. And there's a list here of some of the statewide and regional travel surveys that have been conducted since the year 2000 that have had a GPS augment in them. And that's in California. We did 3 counties with different demographics. Pittsburgh and Laredo each had a small GPS sample. St. Louis, Kansas City, and Reno all had a more significant one. And then between 2007, 2008, Chicago, Washington, D.C., and Baltimore all had pretty substantial in-vehicle augments to their travel surveys. And the methodology is diaries go to all household members. GPS devices are provided for all vehicles in the household. And then we take the vehicle trips that are measured by GPS and compare them to the reported vehicle trips by the household members. And then we can do a comparison and we identify the kinds of trips and the kinds of households that misreport trips, and then that information can then be applied to the larger sample to correct for underreporting. More recently, there have been other uses identified for this same type of data that's collected in these studies. Air quality modeling, congestion analysis, and independent assessments of vehicle miles traveled, travel times. And trip rates have all been explored recently. The other big thing that's happened in the last few years is that GPS technology continues to improve, and the devices themselves have gone from really not having anything available, commercially available, to log a significant number of GPS points easily with sufficient battery capacity to do it for a typical travel survey, which would be at least a day. But in the last several years, there's been almost a proliferation of these devices. So internet search can reveal up to 20 or 30 devices that are GPS data loggers. And then you can kind of call through that list and identify anywhere from 3 to 5 that are really robust enough to meet the needs of the studies that we're conducting today. And so we have switched our methodologies to wearable devices. And just because the technology supports a wearable or person-based device doesn't mean that that's the answer all the time. Sometimes vehicle-based solutions are still the best because there's no respondent burden. Once you put the device into a vehicle, you can leave it there for a week or 2 weeks, and if your interest is really road congestion and travel time and delay patterns of vehicles in your area, then that's fine. But if you're looking for non-motorized travel, if you're interested in bike and pedestrian activity or transit usage, then the wearable device is a much better solution. And so wearables allow us to do multimodal studies, and like I mentioned, you focus on walk, bike, and transit usage. There was some very early GPS applications in Atlanta in 2001, and then in London and Portland there were other wearable pilot studies conducted exploring the use, but the devices were a little bit big, a little bit clunky. It proved that the data collection could be done, but the device wasn't quite ready yet. More recently, Chicago and Indianapolis both have had wearable GPS augments to their travel surveys. Upcoming studies in Boston, the New York City region, Cincinnati, Jerusalem, are all planning wearable GPS components. And the last two, Cincinnati and Jerusalem, are actually planning a GPS-only study where the households don't get diaries. They only get GPS. And then that data, they get GPS devices, the devices are collected, the data is processed, and that data replaces the need for the travel diary. And Portland and Denver are also considering a wearable component to their upcoming household travel surveys. I'm not sure if you know it, but Oregon is actually conducting a statewide household travel survey right now where each of the major or the metropolitan planning agencies are having their own travel survey conducted. And Portland is one of those. And GPS options for both the vehicle solution and for a wearable solution are under consideration right now. The most recent trends in the use of GPS are not just to give diaries and GPS equipment to the same participants, but to remove the diary from the equation and just give the GPS data logger. And then you can process the data and feed it back to the participant either by phone or web or face-to-face interview and ask them to fill in the missing details and to confirm what you've imputed from the data, or you don't go back to them at all. You just impute everything based off of the information available. And where initially deploying for 1 day was the primary point, because these travel surveys are 1 day snapshots of travel behavior, now it's becoming much more prevalent that once you go through the expense of getting the equipment and deploying it to them, why not leave it there for more than 1 day? And that way you can observe the day-to-day variability in people's travel patterns, which is probably much more representative than a single day snapshot. So this shows a few images. The two on the left are ones that were created by GeoStats in the early 2000 to 2003 range, because there were no other commercially available products. GeoStats is not in the business to develop devices. We kind of did this as a stopgap measure so we could get out there and collect data. The one on the top left is what's used for vehicle studies, and the one on the lower left is a wearable. And this wearable on the lower left is actually the one that we used in Portland in 2004, 2005 to do a wearable GPS pilot study here for travel surveys. And on the right, you see this is like the latest generation of GPS data loggers. All of these can collect at least 60,000 points. They all have battery capacities up to 20 to 22 hours between recharges, so you can ask participants just to recharge nightly like they recharge their cell phones. And they're very easy to wear. And so this is what people are using now in our studies. Once you process the data, then there's many different things you can do with GPS points. You know, points are processed into trips, and there's a lot of software involved with doing that. This is a thematic of one person's travel around Atlanta, where each trip is color-coded in a different color, and the red circles indicate stops during the day. And you can see Georgia Tech is located to the left. Our office is about half a mile away from Georgia Tech, so it's one of our employees who was traveling to different places during the day. Okay, and when you use GPS in travel surveys, much of the typical trip information that's reported in a diary can be derived from the GPS data itself and from other supporting information, such as GIS layers and information that you can collect from the households when you first recruit them. Tell me your 5 most frequented destinations and the addresses of them. And so then when you actually get the GPS data, you can fill in much of the missing detail. And this is to show you a GPS trace on the left, and then when we bring in aerials, we can very clearly see that the behavior that's not so obvious on the left is actually parking space search. Okay, I'm going to switch to physical activity studies. In the health arena, health researchers have the same needs that transportation planners have, in that they need to get objective measures of travel and physical activity. And they have the same issues with self-report methods. And in addition to having people report their travel patterns, they also ask them to report levels of physical activity. So it's very hard for people to be able to understand exactly how to report amount of physical activity and intensity of physical activity. So over the last decade or two, there's been much more research into looking at other techniques, and I'm sure that you've heard about the pedometers are a very common tool right now in the 10,000 steps a day program, and the accelerometer is one step up from the pedometer in that it not only collects step counts, but it also can measure level of intensity of physical activity. And so that's been a major breakthrough, and accelerometers have become pretty much the gold standard for measuring physical activity in a lot of health studies. This is an example of one type of accelerometer. It's called the actigraph. It can be clipped to the waist. It's supposed to be attached right onto the waist band, or it can be provided with a belt. And these are some plots of the data that comes off of it. This was on a 14-day deployment, and you can see different patterns of activity from 3 different study participants. The height is intensity of activity, so if they're walking or running or exercising hard, then we're going to see measures above the 4,000, 5,000 mark, and you can see there wasn't a whole lot there. And on the last one, you see that they're actually engaged in quite a bit of lower level activities compared to the first participant especially. Now, because the actigraph or accelerometers are mounted on the hip, they're really good at measuring physical activity of running and walking. And in bicycling, they're not quite as good because people don't do a whole lot of movement at the hip when they're bicycling. And so this shows you the typical profiles and activity levels or intensities for the 3 different non-motorized modes that we were experimenting with here. This is an example of a display within some software that we've developed where one of our grad students who's a triathlete went out to Stone Mountain. I think it's the largest exposed piece of granite on the face of the earth. It's located right outside of Atlanta. And she did 3 laps around it. She did a walk, she did a run, and she did a biking. And so we're seeing all of the 3 paths on top of one another, and the big white thing in the middle is actually the mountain itself. It's kind of hilly out there, and so what we're looking at here is at the bottom of this screen, right in here, is the speed profile. And so you can see that when she was going downhill, she actually picked up quite a bit of speed, up to almost 30 miles an hour, and when she was going uphill, sometimes she really slowed down. And over here we have the level of physical activity, and this is the same trip that we just saw on the last screen, which was in the 3,000 to 4,000 counts per minute, which was lower than the walk because of where it was mounted on the hip. And then this software allows us to process GPS points into trips. It summarizes the trips down here, and we get some animation control so that we can reenact each trip as it's being made. And I just wanted to throw this up, that once you get GPS and physical activity data collected together, you can match them on the date and timestamp. And there's all different kinds of ways that you can explore that data. And this is something that we pulled into Google Earth. And the image on the top, these are the same trips, the 3 trips that she made around the mountain, where in the top left is the one where the height is based on level of physical activity. And on the bottom, it's based on speed. And we had to scale it up and down just a little bit so that we could break out the different trips around the mountain. Okay.
Just before you move on, were those all running trips,
jogging trips?
jogging
Use the
trips?
microphone when you ask a question.
Oh, yes.
Thanks.
Thank you. Hi. Could you tell us, were those all running trips around the mountain?
No, one run, one walk, one bike.
Okay. Thanks.
Yep.
And could you distinguish them? It didn't seem to show in your graphics exactly. Were they distinguished by color?
Well, in this graphic here, the question is, are they distinguished by color? You can actually see that there's 1 or 2 active trips. The one in pink is always the active trip we're evaluating, and then the other trips are underneath it, and you can see these green points over here. But these are not displayed with any thematic other than the fact that this is the selected trip. But for each point, we have both a speed value obtained from the GPS and a physical activity intensity level and step count as collected on the actigraph or accelerometer. So here, there are 3 trips, walk, bike, and run, in the 2 different thematics, the top one being physical activity and the lower one being speed. When we do these studies, one of the things that we provide to the study team is a website where they can actually explore the data as soon as we receive it and process it. And so this is a screen grab from one of our projects, but it's the same student information that we saw before. We display on the map portion a work icon for the geocoded work address, the school icon for where she goes to school, and then the home icon for where she lives. And so this helps us when we're processing if we have all this information in advance. For this particular trip that's being displayed, you can see that it starts off with a very low speed profile, and then the speed goes up well above 20 miles an hour. And so this is a case where she started off walking, and then she got into a car, and then you see the physical activity levels are extremely low, and this is what what a car ride looks like. So you can see where you can develop profiles of what different types of activities look like, both from a speed perspective and also a physical activity. And putting the 2 together gives you even higher levels of confidence that what you're imputing as the travel mode or the behavior is in fact true. The cut points that we're using are standard cut points for physical activity studies. Light is based on less than approximately 2,000 counts, and the count is a count of intensity in a 1-minute epoch. And then the moderate goes up to the next level where vigorous is the highest level. And the Surgeon General, I'm not sure how many years ago, said that all adults should be getting at least 30 minutes a day of moderate and vigorous activity, physical activity. So you'll see the terminology in here that's MVPA, and that stands for moderate vigorous physical activity. And the cut point that's displayed here is just the cut point between light and moderate. So while she was walking, she was above the moderate threshold. Other information that we provide as soon as we process the data includes a breakdown of every trip made, where we have the duration and distance of the trip, the average speed, and the maximum speed. And this also provides pretty quick insight to being able to identify which trips were the walk trips. And so there were 3 trips here where the speed did not go above 4 miles an hour. And each one of these links that beside it then goes to the map with the speed and activity diagram that we just saw. In the bottom, you get a summary of the total activity for that day. And so for each day, the number of trips made, the total minutes spent traveling, the total distance traveled, the number of hours that the actigraph was actually worn. This is a pretty important requirement in physical activity studies. The standard is people need to wear it for 10 hours a day. We hadn't told our grad student when she was collecting the data for us that she needed to wear it at least 10 hours a day, so we can see that there was only one day where she exceeded what is considered the standard or minimum in physical activity studies. And then we broke the total amount of wear time by day into inactive, light, moderate, and vigorous categories, and then we did a percent to total. But you can obviously see we could also do just a raw number of minutes count in each activity. And then the other thing we do is we go ahead and create a minutes of activity table that's basically a trace through the entire time a participant is instrumented with the level of physical activity for that minute, the number of counts measured for that minute, and then did it fall into which activity bin. We determine if they're indoor or outdoor based on our GPS processing methods, and then the starting latitude and longitude, distance traveled during that minute if they were traveling, and then we can provide average speed. And there's a host of other variables that can be provided. But once we do this, then we can aggregate this up to generate these bouts of moderate and vigorous activity, which are kind of one of the key focus areas for physical activity studies. Are people spending enough time in these 2 categories? So applications for transportation and health. You can apply these 2 technologies to do studies of current behaviors at a fixed point in time, or if you're scheduling some type of new service, such as a new bike lane or a new transit service, and you want to evaluate how people's behaviors change because of that type of infrastructure change or policy change, then you can do a before and after study. And so for transportation and health applications, these include things like bike and ped facilities, transit usage. I know a lot of transit agencies are very interested in how people access their locations, whether they're bus stops or train stations, so you can get the full walk or bike trip or even car trip made to transit facilities. There's a lot of interest in looking at the built environment and the factors that influence physical activity, whether you're getting it as secondary to your transportation mode or whether you're actually there exercising and that is your primary purpose. And not only at the street level, but you can also do an analysis based on new types of communities that are planned, like transit-oriented development or even the new urbanism. You can do a before and after study of does it really improve people's quality of life based on whatever factors you define as important. A lot of the studies we're looking at, the quality of life has to do with, are they getting more physical activity? Are they outside more? Have they reduced their number of trips in a vehicle? And are they taking more walk trips? And then children have become a very high focus area recently with the growing obesity levels across all age groups, but especially in the children's age range. So looking at playground or park usage, walking and biking to school and the impact on those types of behaviors on levels of physical activity. So I thought I'd take a few minutes and just talk about one of the studies that we did with the UC Berkeley School of Public Health, where they had a 8-year study of children who had asthma, and they were looking at the effects of pollutants in their environment on their health. And this study started, I think, around 2001, 2002. In the first wave of it, there was no GPS or accelerometry instrumentation, but they did have pollutant sensors at the homes and schools of these participants so that they could measure particulate matter pollutants primarily. And they would ask the kids to fill out diaries of where they went, how much time they spent indoor, how much time they spent outdoor, and what time of day they were doing the traveling. But of course, they found that it wasn't always that accurate. So we did a small pilot study then to demonstrate that if we put GPS on the children, we could use that data and it would give them a much better understanding of how much time the children spent indoors and outdoors and at each location where these sensors were, and also where the sensors were not. So in 2006, we added GPS and accelerometry. 150 children in this study between the ages of 18 and 17 participated in this part. And all children were deployed with devices during 5 days during their school year. And the standard deployment period started on they would start wearing it on a Wednesday and continue wearing it through Sunday. And each night they were asked to recharge the GPS device. The accelerometers had power for up to 15 or 16 days, so they didn't need to be recharged. And then some children were deployed again in the summer months so that there could be some comparisons between levels of physical activity and some of these other variables between school year and non-school year time periods. The object was to look at amount of time spent indoor and outdoors by location, and also the amount of physical activity obtained at these different areas. Secondary interest was just how much time did these kids spend riding in vehicles, and there's some exposure element to that as well from a pollution standpoint. So this shows an example participant wearing the two devices. On his right hip over here, you see the accelerometer. On the left hip, you see the GPS device. And this shows a map of Fresno with GPS points collected in the study, loaded onto the street network. The little red spots on here with the tiny little flags are the schools. We are not showing the home icons for reasons of confidentiality. But what you see here is a thematic, all the GPS points are color-coded based on levels of physical activity based on the bins that I described earlier. And the highest level are the darkest green, and the yellow gold is the very lowest level, and that indicates where they were riding in cars, and it's kind of confirmed by the fact that it overlays the street network pretty clearly, and there are pretty much straight lines. And then you can kind of, if you look at where the schools are, you can see how much outdoor activity occurred at some of these different schools. So down here, there was quite a bit of outdoor activity. We see a lot of dark green. Over here, there really wasn't as much. Here, we also see quite a bit of activity outside. Answering the question of, based on day of the week, where were the moderate and vigorous physical activity obtained for the children in the study? This shows for the age group 8 to 11 where they obtained their activity, moderate and vigorous activity, on a daily basis. So you can see on the first day, for the participants in the study, it actually wasn't at home or school. But as we move through, you see the yellow line at home. Home did not register high through the school days, but then when we got to the weekend, it became the primary location of where moderate and vigorous activity occurred. This is a breakdown also by location, but this one is an indoor-outdoor. Are the children in the study getting most of their physical activity in the moderate and vigorous energy expenditure categories indoors or outdoors? And you see that they're getting much more moderate and vigorous physical activity indoors on all days compared to outdoors, but you definitely see a bigger drop-off in the outdoor activity on Saturday and Sunday, indicating that the children are getting outside more when they're at school and not being outdoors nearly as much, being physically active on weekends. So this would be a finding of interest for people trying to implement, children's physical activity programs. Other studies that we've been involved in, we did a wheelchair activity study where wheelchairs were instrumented with GPS devices and different types of sensors so that an evaluation could be done of the impact of improving the wheelchair technology on the wheelchair users, and it was a before and after study. So there were different technologies implemented. Some of them were power-assisted chairs that went from manual to power-assisted. Some of them went from standard wheelchairs to tilt in space, which is supposed to alleviate some of the pressure. And there were other types of technologies used. And instead of using an accelerometer, which was very ineffective in a wheelchair user, there were other sensors developed at Georgia Tech to measure wheelchair revolutions so that they could actually capture movement that way. There was an active living research project that looked at trail users in the state of Massachusetts, where people were intercepted on trails around the state and asked if they would participate in the study. And then GPS and accelerometers were delivered to them, and they were asked to wear them for 4 days. And then an evaluation was done to see how much physical activity did these people actually gain from being on the trail versus being somewhere else, whether it was through their travel mode or going to the gym or working out at home. And then for the Veterans Administration, or Veterans Affairs, the blind research component of the VA wanted to do an analysis of how effective their cane orientation and mobility training was in improving the quality of the lives of blind veterans. And so once the blind veterans would sign up for this rehabilitation training, we would deploy GPS and accelerometers to them for a period of 2 weeks, and then they would go to the training for anywhere from 4 to 6 weeks. They would go home, they would get acclimated, and then a few months later we would go back and give them another 2-week deployment so that we could observe, did they get out more? Did they travel more? Was there any chance of they did more independent traveling? Or was it just simply an improvement in their mobility within the home? And that's one of the anecdotal things that we noticed, is that was probably the biggest difference, that they felt more confident moving around their homes, within their homes, than they did before they had a cane. So these study components, I thought I would just run through this quickly. These are the kinds of things that need to be decided when this type of study is set up. Identifying the target population and sample sizes based on what the objective of the study is, and then determining the methods for recruitment. How are you going to find your sample, your participants? And based on the objective of the study, do you need to instrument just one person in a household, or do you need to instrument more than one? How long do you want the equipment deployed? You go through the effort, expense to get the equipment and get it out there. What is a reasonable time period to capture information without it being too burdensome on the participant to use it for more than 1 day or 5 days or 7 days? And are we going to offer incentives to get them to be in the study and to get them to actually follow the protocol for the study? And for most of the studies I've gone over here, there was an incentive offered to the participants, I think, in every case. And it can be structured in a different way based on completion of all days, or it can be paid on a daily basis. You just have to be very clear about what the terms are for qualifying. And then selecting the equipment. I'm not here promoting any equipment, either GPS or accelerometers. There are more than adequate devices available on the market now, and there are people who have written papers on the different devices that they've used, and I'd be glad to tell you what we've found success with, but that's just a decision that needs to be made. And then once you select the devices, you need to decide how you want to configure them. The GPS devices come with a logging frequency, so you can say how frequently to collect a point. You can tell it to save space. You can tell it, don't log when the speed goes less than 1 mile an hour, or don't log points unless the unit has moved more than X meters. And so that type of logging frequency and logging rules, you can also tell it what variables to log. So these are all different things that you can control. The same thing with the actigraph. or activity monitors, the 1 minute period for counting intensity was the standard, but the latest research is really going to much finer resolution of epochs, that's what they call them, and they're down to, some of the researchers are even looking at how much activity you have in a second. So they're setting them at the second level. But 1 minute's the standard, and the trend is to go lower. You need to develop materials other than providing the devices themselves that are part of the whole study itself and protocol. Determining the device deployment and return method. Are you going to, hand the devices out? Are you going to have the participants come into a central location? Are you going to try mailing them out or shipping them out? And there's trade-offs associated with each method option. Once you get the equipment back, then the fun part starts. You need to, download and store the data, process the data, and turn it into information you can use, analyze it, visualize it, and then generate your reports. So in summary, the use of GPS and accelerometer technologies allows for objective passive measurement of travel and physical activity. There's reduced respondent burden instead of reporting the things that we're measuring, and you get very high resolution, high accuracy data for multi-day periods. And these rich, robust data sets can be used for the primary study purpose, but there's often many secondary uses of that data. And it's an interesting area for me because we do many studies where the primary intent of the data is realized, and then we move on to the next study. And there are so many more things that could be gleaned from those data sets for different purposes. And then because of the geospatial component of these data sets, I tried to include a few different visualization techniques here so that you could see that there's just many different ways to explore the data, not just in a database, but visually in a GIS environment. The device technology is no longer the limitation, but ideally we would like to see the GPS and accelerometer technology merged into a single device. I think that's the wish for everybody in this field. And now that the need for the device is no longer the focus, the teams can really focus on some of the study protocols and methodologies and how to motivate compliance. And data processing itself can be done in-house if you have the skills and the people. There's also outsourcing that can be used where the data is collected and processed and then delivered into a database where you as a study team can focus your efforts on analysis and reporting. So with that, I know it's a seminar, so I felt like we needed to end with a quiz. And I just wondered if anybody wanted to take a guess at what type of behavior is displayed here.
Mowing the lawn. Plowing.
Plowing, correct. And this is our software that I showed you before with the animation. This was collected in one of our studies. It does not have a physical activity component. It would be interesting to know what kind of vibration that an activity monitor would capture on a tractor with somebody who's out in their field plowing for, the duration of this was 109 minutes for the particular trip in pink that appears here. And you can see that there were several other trips made in this particular farmer's day.
And the red circles are rest stops.
Yep. Okay. With that, I'll turn it over to questions.
And remember to use the microphone.
So do these devices all have to be retrieved to be downloaded, or are there any that can uplink and send the data in?
Well, there are devices, obviously, that do have wireless capabilities. The trade-offs there have been, one, that they can be expensive, and if your participants break them or lose them, that can be a problem. A lot of the data transfer subscription rates are kind of high, and so you make a commitment to a wireless provider. I'm buying, 100 iPhones. I need data service subscriptions on these for the length of a year. And so the primary methods that have been used have not used that technique. It certainly would be helpful. It would allow the devices to be out there for a much longer period of time. But the trade-off there is, do you want a few participants for a very long period of time, or do you want a lot of participants for a shorter period of time? So it's certainly an option. You know, people have talked about, I mean, I'm sure you've heard that iPhones have GPS in them, they have accelerometers in them. People are already looking at that, but if you develop an application that goes on an iPhone, then are you providing the iPhone to children, or are you going to try to find participants who have an iPhone and get the application put on there? So what we have done is we've tried to very much standardize the technology so that there's no variation at all that can be attributable to the device itself. And so we've tried to find the lowest cost devices that have the most functionality in them to meet the requirements of the study. And if we lose a few, we're not going to be upset. And that's part of the whole process. Yes?
Have you considered using, for collecting bicycle data, some of the common GPS units? Or it's a regular cycling computer that has a GPS unit?
Well, I'm not sure if they're collecting physical activity levels on them, right? They are connected to heart monitors, I know, but I'm not really sure that they're getting physical activity in a way that is useful.
Yeah, I can't remember exactly what they collect.
They can compute power output because they can know what gear you're in. You can know the slope, and you can know the number of revolutions, and so you can back off some power output at least.
Yeah, for
Right.
biking.
Right. And anytime we can find another data stream that'll have a date and time stamp in, then that's just an additional source of information that can be brought in and improve your algorithms. Chris?
Just on that question, do you have any special procedures you do to sync time? Because whenever I've tried to match time from a couple different devices, it's been like an endless day.
Well, for the GPS data streams, the global positioning system is synchronized to the atomic clock, and it outputs in universal time coordinates, or UTC. So the critical thing to note there is when you're converting to local time, make sure that you get your offsets right. Make sure that you account for changes from daylight savings to daylight standard time, because people are going to be instrumented when those changes occur. But that's your primary benchmark. For the other devices, like for the accelerometers, a lot of them are capturing increments off of the time that you tell the device to start logging. And then when you download the data, it takes the date and time stamp on your computer, and it populates the date and time fields of all the records that are coming off of the device. So one of the things that we do is we make sure every computer in our office is synchronized through the internet to the atomic clock so that there's no clock drift. So it depends on the device that you're using and what the characteristics of how it gets its date and time stamp, and then you try to accommodate that. But drift is an issue, and depending on the device, sometimes you can handle it and sometimes you can't.
How much data cleaning is needed for the wearable GPS devices, and would you describe it as limiting the utility of the data right now?
Well, in-vehicle GPS data is much cleaner to process because there's not nearly as much noise. One reason in the past was because the power was only provided to the devices when it was in the vehicle itself. When a device is not moving, whether it's in a vehicle or in your house, if it's in a covered structure, sometimes you can get the signals, but the device is not able to capture or to calculate a good position. So you get noise and you get spikes, but the noise tends to have very distinct patterns in it, and after you've played with the data for a little while, you can write software that can parse that noise out. It may not be 100% accurate, but it's probably more than enough for it to meet most of the needs. The harder things are like if somebody is in their house and they're wearing a device, and they're in their house, you're getting these little noise spikes, but then they go outside and they're like working, gardening right outside the house. That type of thing where there's only 5 meters of difference between in-house activity and outdoor activity, at times that can be hard to differentiate. But if a child is out playing in the yard, you really can tell the difference between the the noise that comes from being in a house and actual play activity outside. Did you have a question? No. Go ahead.
Maybe this is a very basic question, but what is the definition of physical activity? Should I jump to be considered as physical activity, or if I move my hands, or do this?
Well,
this can be monitored, or
well, the device itself is monitored on the hip. The physical activity researchers will spend a lot of time focused on exercise and measures of physical activity based on different exercises. But there's a whole growing area of research that has to do with lifestyle activities, whether you're working in the house or working in the yard. And those also give very good health benefits. And so it's really a matter of movement. I mean, that's what the physical activity monitors are measuring, is movement. And so some people think, well, maybe we should put a device on the wrist and on the foot and on the hip, and that way we get everything. And there are some researchers who actually look at all of that, and they capture different types of activities because it's not just on the hip. Jennifer?
So we had a question come in over the web about how accurate the GPS data is. How often do you lose signals in urban canyons?
Right. Good question. The GPS specifications that we've seen are within 5 to 10 meters most of the time. We are seeing very good data. Even in urban canyons, the software or firmware that's on the receivers that calculates location can vary a bit from device to device. We've done once or twice a year, we actually do a technology assessment where we identify the 5 to 10 devices on the market that look like they meet the needs of travel surveys and physical activity studies. We then acquire 2 of each device and we run them through a battery of tests so that we can compare. For the most part, the accuracy portion, they all perform fairly well. Where we found that they may differ is things like performance in urban canyons, because the actual firmware that comes on the device may correct better on one device than another. I always tell people, GPS is not foolproof if the people don't wear it, if they don't recharge it, or if they decide to play with you and throw it in the trunk of their car or throw it in the back of their backpack and it never comes out, then the data is not going to be optimal. But a lot of times you'll still get traces when they're wearing them, even in a suboptimal mode, that you can process and get good trip information out of.
I've got a couple of business questions. How many other organizations similar to yours are doing these types of studies? At what level of magnitude? And who in general is paying for them, for the studies?
For household travel surveys, there are mostly researchers who are affiliated with academic institutions around the world, who have been experimenting with processing GPS data into trips and imputing information. As far as companies go, I can guess, our company does most of these. There are 1 or 2 other companies out there who I would say are playing with it a bit. There's no one else who's really made it a primary business focus. The second question was, who are the clients? For household travel surveys, the clients are almost always metropolitan planning agencies or state DOTs, because they are the ones who are required to collect data about personal travel in their planning area. Physical activity studies, a lot of those studies are funded through the NIH or the Robert Wood Johnson Foundation Active Living Research Program. And then you'll find other entities like the Veterans Affairs, who have their own internal research branch, and that they're interested in studying their own population that they're responsible for.
Since using the new GeoStats technology, has there been any decision made based on the results you guys acquired from individuals?
For the VA study, one of the things that we found is we were overly ambitious in thinking that blind elderly veterans with the average age of 73 would wear GPS and accelerometers for 14 days before and 14 days after. even if we offered them $50 in each deployment period. And so that helped us define or refine that 14 days is probably too long of a period of time. And it's all about managing participants' expectations. In the health field, 5 days seems to be a pretty typical deployment period, or they may deploy for 7 days and then hope to get 5 complete days out of it. The one finding from the VA study that we found very interesting was that quality of life was not what we thought it would be. We thought we were going to see more traveling out of the home. But what we found through talking with participants and also looking at their data is they actually were moving around much more inside their home. And they really felt that that was the improvement in life that was important to them. It wasn't that they needed to get out of the house. It was that they felt confident to move around within their own home rather than just sit in the same place. And so each study has findings like that where you get in and you look at it and you glean more information out of it. And sometimes you're finding things that you never intended or thought about when you were first designing the study.
Is there any indication that having an actual physical device on your body would influence behavior? Would people, be more active knowing that they're being tracked?
Well, I think that in diaries where people self-report physical activity, I think that there's actually some findings that people over-report physical activity because they think they should be more active. Where when you're wearing a monitor for 5 days, you may try to be more active for a day or two, but your real routine's going to come out at the end. So if anything, the passive monitoring for longer periods of time will get to the truer behaviors than what people tend to report. Yeah.
Do the participants get to have access to this data and be able to see their own results?
That's a great question. We have not done that in our studies. We offer that to the client if the client is interested, and it's a very good incentive. I suggest that if we offer that in a study, that it comes at the very end and not like after a first wave, because you really don't want to influence any behavior in the study by showing them anything that would cause them to change their behavior in another stage of the study. But I do think it's a great thing to offer. And another thing that you can do, and we've proposed this before also, is show how they compare to the overall study population. So, people kind of like to know where they rank. You don't necessarily have to tell them you're going to show them where they rank, because then it might be more of a competition. But in the end, you give them something. And a lot of times, researchers like to say, when they give them the final incentive or the final map of your trips, say, would you be interested in participating in a study like this again in the future? And that's a very good way to get a candidate pool for either a panel study or just your future studies.
It seems like more and more people these days have cellular telephones. Do you know if it's possible to request geolocation data from the cellular network operators?
Each network provider has their own constraints on what they will make available. I know, for example, there are some traffic data providers who are using cell phone-based techniques to calculate travel times through a corridor, and then they sell that data to traffic data third-party providers. It's a very limited amount of information that's provided. It's usually the geographic precision is not precise at all intentionally because of the participant, in this case the user, confidentiality. And so I would say with cell phones particularly, I'm not certain that people, unless they opt in to having their phone used as a tracking probe, that information is going to be made available to planning groups. On the other hand, personal navigation devices like a TomTom that you buy in a store, when you first install that software, it comes up with a screen that says, would you be willing to share the information off of your device if your information is anonymous? And if you hit yes at that time, they never ask you that question again. But they're collecting the data. They're not transferring it real time most of the time. But when you connect the device to your laptop again or your PC again, it may download all of your traces, and then it goes into a database where that data can be sold after your trip ends or anonymized to do like congestion analysis and other types of traffic flow studies. And I know that they're doing that in the UK, United Kingdom.
Hey. Sorry. Okay, so I think that's all the time we have for today's seminar. First of all, let's thank Dr. Wolf. And next week we have Justin Soltani, Technology Officer of Zeta Partners. And Justin will be talking about technology for assessment of mileage, weight, and congestion taxation. If you are in the seminar, registered for the seminar and you didn't get a chance to ask a question, if you could please write your questions down and turn them in to me on your way out the door, that would be great. Thank you.